I will be doing my project on recombinant DNA technology for insulin production. Introduction. Recombinant DNA technology for insulin production is the process of creating insulin by inserting the human insulin gene into a bacterial plasmid. I chose this because my mom has type 1 diabetes since her body doesn't create insulin naturally. The image on the right shows the basic steps in this process, and then on the left it shows a healthy pancreas producing insulin versus a diabetic pancreas. The science of it. Basically, scientists take a human insulin gene, place it into bacteria or yeast, and allow it to create human insulin. It's chemically identical to natural insulin. The steps in the process are: first, choose plasmid that contains origin or replication, selected markers, and restriction enzyme sites to carry insulin gene. Next, cut DNA and add plasmid so the sticky ends can join together. Third, mix DNA and plasmid in tube. Next, add ligase to tube. Lastly, transformation is done by heat, shock, electroporation, or chemical treatment to insert plasmid into bacteria. The science continued. Recent advancements focus on creating insulin through novel formulations, with a goal of improving concentration, convenience, and especially absorption. This is done by taking recombinant insulin, adding small molecules like vitamins and stabilizers that affect absorption rate. This image shows the time it takes to work based on different absorption rates. Benefits to society and intended uses. Some benefits include creates a ton of insulin cheaply and safely, obviously essential for diabetics, allowing for personalized medicine to play a role because insulin can be engineered for specific needs, such as dosage, what type, and how fast. New technologies have emerged such as pumps. Recently, scientists have shifted focus to engineering insulin analogs, basically more advanced than normal insulin. Recent advances have focused on ultra-rapid insulin because old insulin used to take longer to work. Now it's more consistent and convenient. New trend of novel formulations. This is how insulin is altered into these analogs. Scientists are starting to focus on novel formulations to make insulin faster, temperature stable, and more concentrated. It's very pure, but we're trying to get it to 100%. Intended use is to produce insulin for people with diabetes who can't get it themselves without having to worry about scarcity, cost, and reliability. Development. Insulin for diabetics used to come from pig and cow pancreases. In 1982, a clinical study revealed recombinant insulin could be a substitute for human insulin. Recent developments focused on analogs I talked about for rapid and long-lasting action. Now it's becoming nearly identical to human insulin as seen in the chart. This chart shows almost equal cell viability from neutral and recombinant insulin at different concentrations. This chart just goes to show how they're almost identical. Future. The future of recombinant insulin is very bright if they continue focusing on insulin analogs, as this would combine with personalized medicine by altering insulin for individual specific needs. New ways of insertion is also how this is becoming personalized medicine, such as using an inhaler or patches instead of shots, which is great because some people can't do needles, so this would be a great option for them. Smart insulin is an evolving field, focusing on making recombinant insulin able to immediately react to glucose level changes. This is especially helpful for people who experience blood sugar spikes after a meal. Digital monitoring, such as the pump my mom has that gives her recombinant insulin, is great as well. Overall, as scientists continue to create insulin through novel formulations, the future is looking very bright. Ethical concerns. While this is pretty cost-effective compared to other biotechnologies, it still does cost money that healthy people don't have to pay. This may cause underprivileged people to struggle. Genetically modifying organisms can be seen as unethical. Unknown new diseases could be side effects, or digital technologies could also bring up the risk of data security because there's so much information on them. However, it is much more ethical than the old use of animals. A breakthrough. While recombinant insulin has been around for a while, new technologies could be leading to a breakthrough. With the biggest concern being quality control, advancements in control systems and process analytical technology could result in less waste. Scientists are playing around with adding stabilizing agents, which is especially helpful for people without access to refrigeration. Converging this with digital technology could significantly reduce the price. Preliminary trials are being done of cell-based approaches to use this biotechnology to restore internal insulin production. This breakthrough is possible and very promising. In conclusion, recombinant insulin is chemically produced by using a bacterial plasmid. The recent focus on insulin analogs and using novel formulations is creating a bright future for diabetics, as scientists continue with these advancements and more, such as using CRISPR to correct diabetes-causing mutations. Patients' quality of life will improve. I have seen my mom benefit from recent discoveries in this field, and I know it will continue to improve even more as it becomes more personalized. Challenges. Everything must meet rigorous Food and Drug Administration guidelines. Producing large batches is tricky to get approved because it concerns with viability, efficiency, and safety. Innovations involving glucose response mechanisms have to be very safe so hyperglycemia doesn't occur, and limited competition in this market is very bad for the economy. This is my works cited slide, and this is my image citation slide.